Welcome to lesson 4 of our data representation topic. Today we will look at how the computer stores and represents graphics in the forms of bitmap graphics and vector graphics. Our learning intentions are as follows. By the end of the lesson, you will be able to describe how the computer stores and represents graphics, understand how a computer stores and represents a graphic using a bitmap, describe the advantages and disadvantages of bitmap graphics, understand how a computer stores and represents a vector graphic, and describe the advantages and disadvantages of vector graphics. Here is the success criteria for today's lesson. I can explain how the computer stores graphics using bitmaps. I can describe the advantages and disadvantages of bitmap graphics. I can explain how the computer stores graphics using vectors. And I can describe the advantages and disadvantages of vector graphics. As always, success criteria should be referred to throughout the lesson. Again, this can be used to assist you in looking at areas of development and next steps. Let's start off by looking at bitmap graphics. A bitmap graphic is represented by taking each individual pixel or picture element and allocating a binary value to it. In monochrome or black and white graphics, we use a 0 to represent a white pixel and a 1 to represent a black pixel. For colour graphics, this is far more complex. Colour graphics are allocated binary values of more than 1 bit. Photographs, for example, would be allocated a 24-bit binary value per pixel. This would determine the number of colours and shades of grey that can be represented by each pixel. Each pixel would therefore be more detailed. In this case, our overall graphic would be more detailed. In this example, we have a bitmap image to the left and its corresponding bitmap to the right. In the bitmap, each pixel is allocated a binary value, a 0 for a white pixel and a 1 for a black pixel. In the top row, it corresponds 0, 0 for 2 white pixels, followed by 4 black pixels, 1, 1, 1, and then another 2 white pixels, 0, 0. This process is carried out down the bitmap until complete. The image itself is an 8 pixel by 8 pixel image, giving us a total of 64 pixels. This is its resolution. Each pixel in this black and white graphic will be represented using 1 bit. Therefore, we have a storage of 64 bits or 8 bytes for this image. Colour graphics are a little more complex, where each pixel is allocated a binary value with more than 1 bit. Like so many other things, bitmap graphics have their advantages and disadvantages to be considered. Some of the advantages include that each individual pixel can be edited. They can be used to create complex detailed images, such as photographs. They are normally used with high quality images. Disadvantages would include that every pixel must be stored. This means that even a blank graphic can have a high file size. It's difficult to alter or edit image objects without changing the entire graphic. And these types of graphic are resolution dependent. This means that the image can't be scaled up without losing quality and the occurrence of pixelation. Now let's look at vector graphics. Vector graphics are stored in a completely different way from bitmaps. With a vector graphic, we don't convert and store each pixel individually. A vector is stored as a list of instructions or attributes that are required to create the graphic. Vector graphics consist of objects. Each of those objects has attributes associated with it. The list of instructions will be the attributes that are required to re-represent those objects within the graphic. Let's look at a couple of examples. Our first example would be an ellipse. The ellipse would be the object. This object would have a series of attributes associated with it. For example, a center point and a radius. This would determine the size of the ellipse. If we change the radius, we would change the size of the ellipse. The ellipse also has a line colour, a line thickness, a fill pattern and a fill colour. These are all attributes associated with this object. Our second example would be a simple line. It would be represented as two sets of coordinate points. We'd also have a line colour, a line thickness, and perhaps a line style, which would include dashed or solid lines. Have a think and consider the attributes of other objects that we can include within an image. Objects perhaps like rectangles, triangles, or hexagons. See if you can think and maybe note down some of the attributes associated with these objects. Vector graphics also have their advantages and disadvantages. Some of the advantages include that each object can be edited without impacting on any other object in the image. They can be used commonly to create line drawings, such as architect drawings. They have a low file size, as only object attributes are stored. They are resolution independent, which means they can be scaled up or down without loss of quality. And layering is also possible. This means that one object can be layered on top of another, fully or partially. The main disadvantage of vector graphics is they can't be used for high quality images such as photographs.